Hi friends, in this video let us learn about what is a reactive programming and what is the need of it and how are we going to achieve it. So here in this particular video I am going to just discuss about the introduction of it. So we have previously, like in a previous thing which we were working, all our monolithic application. What is a monolithic application is we have all the applications are being deployed in one particular server which are interdependent on each other, whereas now we have migrated to the microservices where each and every services are interdependent on each other. So they are not interdependent on each other. So how we are achieving it and what is the module that helps us to make it more reactive in the sense, as and when I'm getting a request, I want my application to be more reactive, that is a live streaming of data. It helps me in retrieving a live streaming of data. How it is possible? First let us learn about what is the drawback of our existing application. Okay, so when I go with my imperative programming, what it is the oldest programming model. Okay, that is fine. What is the drawback? It is a sequential execution of threads. So my threads would get executed one after the other, and also it is blocking, and the main point here is they are synchronous. That is the sequential execution where your dependency would be higher in that case. If my one particular module is being interdependent on another, if this particular module is failing and both the modules will not run. So this is how the evolution. You had a monolithic application, you have a microservices that has been put into the pivotal cloud foundry. So what is the need of your reactive programming is scalability, that my applications could scale up, that my transaction per second should be more higher, and latency, that is nothing but the response time. So I get a request, rather than waiting for so long time when the entire API or the entire services finished its processing, I'm getting a reply. I want my response time to be faster, and it is message driven, like for each and every request I send, I receive a message in turn. So my drawback of my traditional approach is I send a request. So I have 200 threads. So say my server can accept a capacity of 200 threads. So I send a thread 1. So it goes into a blocking state as till it is getting a response from this database. So similarly I'm sending a thread 2, and that also goes into a blocking state until it gets a response or a failure message, anything. So all say I have 200 requests that has to be processed, so all my threads would be occupied at this point of time. Okay, so what happens now? So what happens when all my threads are occupied? When all my threads are occupied, what happens? When I'm receiving a new task that has to be performed immediately, I will have no threads left and I have to wait idle until any of my thread is been reverted back. So I will not have any threads left at this point. So how does a reactive programming works? So in a reactive programming you have a thread pool. Okay, so I send a request, send a request, a thread would be allocated to it, say it is a thread 1. So what happens is this thread 1 will inform the database that I am going back. Once you are ready with the response, please invoke a request or send a message, so that a thread would be allocated to get the response and send it back to the person. Similarly, I am having a thread 2. So that also does the same. Sends the query to the database. As soon as you finish, let us know. We will retrieve the response. So this is how the evolution of reactive programming or the need of reactive programming has emerged. So we have a lot of APIs and frameworks that has been there, which is implemented to achieve this asynchronous and reactive stream of data. So let us learn one by one each of it in our upcoming videos. If you like this video, please do like, share and subscribe. Thanks for watching. Bye bye.